Welcome back. In the last episode, we learned how clouds form, how they're classified, and what they reveal about flight conditions. Today, we go deeper, focusing on precipitation. We'll explore how it forms, what types exist, and what they mean for aircraft performance and safety. Let's start with the basics. Precipitation occurs when cloud droplets or ice crystals grow large enough to fall to the ground. This happens through collision and coalescence or through Bergeron processes in cold clouds. In warm clouds, droplets bump into each other, merge, and become heavy enough to fall. In cold clouds, ice crystals grow at the expense of supercooled water droplets, eventually becoming snowflakes or rain. There are several types of precipitation you need to recognize. Drizzle, DZ. Rain, RA. Snow, SN. Hail, GR. Freezing rain, FZRA. Sleet or ice pellets, PL. Showers, SH. Each behaves differently in flight and affects visibility, drag, and icing risks. Let's begin with drizzle. It's light, fine, and falls from stratus clouds. While gentle, it's a warning of possible low ceilings, mist, and poor visibility, especially during approaches. Rain, on the other hand, can be light, moderate, or heavy. It falls from nimbostratus or cumulonimbus clouds. Heavy rain can reduce visibility to near zero, cause hydroplaning on wet runways, and mask terrain or traffic visually. Snow forms when temperatures are below freezing throughout the atmosphere. It falls as crystals and flakes, accumulating quickly. It affects lift, engine inlets, and landing gear. Runway contamination and braking action become critical. Showers, marked SH in METARs, are sudden, brief, and intense. They're common with cumulus or cumulonimbus clouds. Expect abrupt changes in visibility, turbulence, and precipitation intensity. Timing and location can be unpredictable. Let's now talk about hail. It's a form of solid precipitation, balls of ice formed in strong updrafts inside cumulonimbus clouds. Hailstones can range from pea-sized to baseball-sized, and they damage aircraft surfaces severely. Even if skies are mostly clear, a distant CB may still produce hail that drifts miles away from the core. That's why pilots avoid CBS by at least 20 nautical miles, especially downwind of the storm. Next up, freezing rain, one of the most dangerous types. It starts as rain, but the droplets become supercooled and freeze on contact with surfaces below 0 degrees Celsius. It coats airframes rapidly and degrades lift and control. Freezing rain forms during temperature inversions where warm air lies above cold surface air. You might be flying in rain at 3,000 feet, but descending into freezing air at the surface. It's easy to miss unless you check temp profiles carefully. A similar hazard is sleet, or ice pellets. These are frozen raindrops that bounce on impact. While less dangerous than freezing rain, they still indicate cold layers and potential mixed icing during descent. Let's go over icing and precipitation. Rain at below 0 degrees Celsius equals freezing rain. Drizzle below 0 degrees Celsius equals freezing drizzle. Snow equals less icing but poor visibility. Showers equals possible rapid icing in CBS. Hail equals structural threat even with anti-ice on. Understanding the temperature structure of the atmosphere is key. Always review upper air charts or use onboard data to spot inversion layers, icing zones, and transition altitudes. Let's explore a real-world case, URI on approach into an airport reporting plus RA and OVC 006. Visibility is low, rain is moderate, and the cloud base is 600 feet. Expect a wet, slick runway, possible hydroplaning, and challenging visual acquisition of the runway environment. Now imagine a different case. SN-BKN 015. Light snow with a broken ceiling at 1,500 feet. The snow may be light, but the runway could be covered, braking poor, and visibility changing rapidly. Plan to use auto brakes or longer rollouts. Let's decode a sample meta. This tells us snow is falling. Visibility is half a mile. Overcast at 1,000 feet. Runway visual range is 2,600 feet. Surface temp is -4 degrees Celsius. That's a tough approach. You'll likely need category 2 or 3 minima, de-icing, and full braking consideration. Now let's talk about precipitation and radar. Weather radar detects reflected energy, stronger returns equals more intense precipitation. But radar can't see cloud types or freezing rain directly. Use caution interpreting radar images, especially in winter. Radar attenuation is another concern. Heavy precipitation absorbs radar energy, meaning what's behind the storm may appear clear, but it's not. That's why CBS may appear as isolated echoes but contain embedded cells. Use satellite overlays, lightning detection, and PIREPs in combination with radar. No single source tells the full story. Layer your information to build an accurate weather picture. Next up, runway conditions. Precipitation doesn't just affect the air, it changes the runway environment drastically. Snow, slush, or water increase landing distance and reduce braking. Use NOTAMs, ATIS, and braking action reports to update your plan. A report of braking action medium to poor should trigger immediate considerations. Longer approach. Full flaps. Minimum touchdown speed. Use of reversers and max braking. Alternate planning if landing distance is tight. Let's do a safety scenario. You're cleared to land with moderate rain and tailwind on a short runway. That's a red flag. Even if it's legal, ask for another runway or delay your landing until conditions improve. Here's another. You're holding short while sleet begins falling. Your aircraft was de-iced 20 minutes ago. Now you're at risk of cold soaking and losing protection. Don't rush, request another round of anti-icing if needed. Finally, let's link precipitation to turbulence. Convective precipitation, showers, CBS, equals vertical motion and rough ride. Frontal precipitation equals long-lasting with possible shear. Drizzle or light rain equals smooth, but visibility reduction. Always anticipate a performance change when entering precipitation. Let's recap part 2. Precipitation forms through different processes, and each type poses unique risks. Recognize rain, snow, hail, sleet, and freezing rain in METARs. Use radar, temp profiles, and surface reports to assess threat levels. Plan runway use, approach speeds, and de-icing actions accordingly. In the next episode, we'll wrap up this series with part 3, focusing on cloud development, embedded thunderstorms, and how to use charts and tools to interpret complex sky conditions. See you in Meteorology number 29, Clouds and Precipitation, Part 3.